Hi, we are from Group 5, Section 4. We'll present our PBL about double integration in civil engineering field. First of all, for introduction, this part will explain about the definition of double integration as well as its application in the field of civil engineering. After that, this part will also go over the study aim that has to be met at the conclusion of the research. For the background study, the double integration is most commonly used to calculate the surface area of a two-dimensional figure, and it is symbolized by the symbol prime, and by using double integration we may quickly determine the area of the rectangular region. It will be straightforward to solve double integration difficulty if we understand simple integration. Integration is an important aspect of calculus, and there are several forms of integration, including basic, double, and triple integration. We frequently employ integral calculus to compute the area and volume on a very large scale, which will otherwise be determined by simple formula or computation. Double integration is one of the most important things to be understood, especially in the civil engineering, because it plays a very important part to find the area of a region, the volume beneath under surface, and the average value of a two-variable function across the rectangular region. Next, for the problem statement, the question we have chosen is the force on a rectangular dam of width 120 meter and height 60 meter. Instead, imagine that the dam is not rectangular in profile but has a width of 120 meter at the top but only 100 meter at the bottom. The top and the bottom of the dam can be given by line segment y equal to 0 and y equal to 16, while the sides are part of the line y equal to 16 minus cx and x equal to 10 minus y per 6 for the left side, and y equal to 60 plus 6 multiply x minus 120 equal to 6x minus 160, and x equal to 110 plus y 6 per y for the right side as in the diagram. Thus, the dam exits at height y between 0 and 16, while for each value of y, the horizontal coordinate x varies between x equal to 10 minus y per 6 and x equal to 110 plus y per 6. Thus, the surface integral represents the total force I equal to integrate 10 power of 4 multiplied by 60 minus y dA becomes the double integral as shown. So, the question is find the force of a dam. And lastly, for the objective of study, we understand the double integral and be able to know how to apply double integral equation to solve problem is our study objective that should be achieved at the end of the conclusion of this project. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Wali. We will present about the calculation double integral in our group. So the calculation is the force on a rectangular dam of width 120 meter and height is 60 meter. Instead, imagine that the dam is not rectangular in profile but instead has a width of 120 meter at the top but only 100 meter at the bottom. The top and bottom of the dam can be given by line segment y equal to 0 and y equal to 60, while the sides are parts of the line. At the left side is y equal to 60 minus 6x, and change it to the x integral, we get the 10 minus y over 6. And for the part of the line at the right side, y equal to 60 plus 6 times x minus 120, and we get this y equal to 6x minus 660. We change it to the x in x sequence equal to 110 plus y over 6. So after that we will get the total force of the dam with the aid of surface integral equation, which is I equal to integral A k times h minus y dA. We assume that k is 10 power of 4 and h we get the height of the dam is 60 and minus y dA. After that, for the integrate limit, we for the dy we have 60 and 0. For integrate dx we have 110 plus y over 6 and 10 minus y over 6. 10 power of 4, 60 minus y. dA we change it to the dx and dy. So 10 power of 4 we get it out and we integrate the equation. We get 60 minus y times by x and the limit in terms of 110 plus y over 6, 10 minus y over 6 dy. So we simplify the solution and get the I equal to 10 power of 4, integrate 60 and 0 in 6000 minus 140y minus 2y power of 2 over 3 dy. So we integrate it again in terms of dy. So we get the final answer is 10 power of 4 times 84,000 and we get the 8.4 times 10 power of 8 newtons. We can simplify it in the total force is 840 meganewtons.
Assalamualaikum, my name is Muhammad Likul Yasin bin Nur Hazam. My metric number is BF25103. I will present to you guys about literature review of this project. For the first point, an integral in mathematics allocates numbers to functions in order to explain displacement, area, and volume. Next point, double integration is one of the most important concepts to acquire, particularly in civil engineering, because it is used to calculate the area of a region, the volume beneath the surface, and the average value of a two-variable function throughout a rectangular region. The third point, based on the problem, the surface integral is used to find the total force of the dam. The surface integral is a generalization of multiple integral to surface integration. It can be thought of as the line integrals, double integrals equivalent. Next, I will move to the methodology part. In the first column of the table is fact. First, width is 120 meter, height 60 meter, bottom width 100 meter, line segment y equal to 0 and y equal to 60, side part line for left, y equal to 60 minus 6x and x equal to 9 minus y over 6, side part lines for right, y equal to 60 plus 6 x minus 120 in bracket equal to 6x minus 660 and x equal to 110 plus y over 6. Next column, ideas. Using the related formula and using double integration. The third column, learning issue. Find equation of y. Convert to x as parameter. Know how to use integral formula. Able to understand to apply equation to solve problem. The last column, action plan. Make a group discussion. Get some information from lectures video. Do some research by the video. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Habizi, candidate, and the number DF210036. So I will continue on discussion part. Based on the solution for question above, the force on them was applied to the surface integral equation. It is necessary to determine the coordinate of the cross-sectional area of the dam. Then we create the equation using the specified coordinate for the design of them by using this formula. we need to use the integral method. After that, find the value of x and y in the equation, that is using the value of the coordinate design of them. Then the integral equation exists by applying the limit on the value of x and y by using this formula. First, we need to integrate the first inner in the equation. After that, the second one. Lastly, the total force that obtained from the solution for the design deck is 840 megameter. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Oni Samira binti Syamsul Akmal. Today I will present to you the conclusion part. In conclusion, it is possible to draw the conclusion that the equation that were utilized in this problem-based learning study were double integral. This is because double integral is one of the subtopics that were defined from chapter of multiple integrals. In the study, a formulation using double integral was used, integrating across a space with 2 dimensions, which provide additional information. Double integral enable us to do a number of things, one of which is to compute the force of a rectangular dam. This study allows us to prove that double integral can be used to our everyday lives, as it should to generate a problem solution that can be used in any circumstances, especially in our field of study, which is civil engineering.